Okay, so this problem is a right triangle similarity problem because notice that we have this right angle and this right angle. So we have a right triangle that has an altitude. The altitude is, of course, well, maybe not of course, but the altitude is this part that goes from a vertex perpendicular to the other side. So that's your altitude. Okay, now there are three proportions that we need to be aware of. Okay, one of them says that if we take the entire hypotenuse, and compare it to a leg, that is the same as comparing this hypotenuse of my smallest triangle to its leg. So notice there are three different sized triangles here. There's the largest, there is a large right triangle where this is the hypotenuse, this is the short side, and this is the long side. There's a medium-sized triangle where this is the hypotenuse, this is the long side, and this is the short side. And there's also this smaller triangle where this is the hypotenuse and this is the short side. So I'm going to compare the hypotenuse of my largest triangle, which is 9 plus x, over the short leg of the largest triangle. And then I'm going to compare the hypotenuse of the smallest triangle to its short leg. Okay, and I get this as my proportion. So I saw by cross multiplying, I get x squared plus 9x. Over here I get 36. So I have an x squared and an x and a number, so I'm going to make a quadratic by subtracting the 36 from both sides. And now I'm going to factor what numbers multiply to give me negative 36 and add to give 9. And hopefully you're saying to yourself why those numbers are 12 and negative 3. Okay, two of the factors of 36. So that means x plus 12 is one of my factors, one of my things that I have to multiply together, and x minus 3 is the other one. So when I solve these, I get negative 12 and I get positive 3. So because this is geometry and we can only have positive lengths, we throw out the x is negative 12 and we get an x value of positive 3. Okay, and now I'm going to switch gears and use this proportion. If I compare the short leg of my small triangle to the long leg of my small triangle, that needs to be the same or in proportion to comparing the short leg of my medium-sized triangle to the long leg of my medium-sized triangle. And I get this proportion, which is quite fantastic. Y squared equals 27. So square rooting both sides, y is about 5.2. I'll say, without using a calculator, that's as close as I'm going to get, so 5.2. And then the last thing I can do is set up this other proportion to find z. Okay, it's the same as the one that we started with. So if I do that, I have 9 plus 3, which is now 12. So 12 over z is in proportion to z over 9. Okay, so I'm comparing the hypotenuse to the long leg, and then this hypotenuse to its long leg of the medium-sized triangle. So z squared equals 108. Square rooting both sides, z is about 10.4. 10.4 sounds good. Okay, so there's proportions that that depend on which sides of which triangle you are trying to compare. Okay, small triangles compared to medium triangles compared to large triangles.